Hi, I'm Alex and I'm a H1 chemistry student. So today we're going to be doing a chemical equilibrium question, and these are in general very nice questions just because of how predictable they are. Most years they follow very similar trends, just a few definitions you have to learn off, and then the same processes for working out the values towards the end for most of these questions. Getting into this now straight away, we're given a massive paragraph at the front, which is filled with information. So again, I'd always recommend just going through this, underlining everything you need, and then we'll come back to it again when we need it. So I'll be looking at this. So when 4 moles of steam, so underline that, and 1 mole of carbon monoxide were mixed together at temperature T in a container of fixed volumes. That's important that we note fixed volume. They produced hydrogen and carbon dioxide, which is given by the equation below. We're also given a heat here, which is released in this equation. We'll fly in now to part A, which is very much just definitions and a small bit of working out, but nothing too difficult. Part I, explain what is meant by chemical equilibrium. And this is a very simple concept, just the forward and reverse reactions have equal rates. There is 2 acceptable answers this year, so you could have said what I've said here, the forward and reverse reactions have equal rates, or that the concentrations are constant, either or works. And for this, you'll get 5 marks in total, so really quick and easy 5 marks to pick up, just for a definition. And then part 2, write an equation for the equilibrium constant Kc for this reaction. So as we know, this is just one of the formulas that we learn off. So we have Kc equals the products over reactants. So in this case, you just look at your chemical equation and all your products are on the right hand side, all your reactants are on the left hand side. So right as it is here, so H2, which is hydrogen, and we're going to use square brackets here because we're talking about concentrations. You will lose marks, unfortunately, in this question if you use round brackets. It's very important to write in with square brackets. And then we have our carbon dioxide, CO2, square bracket, over H2O, which is our water. They mentioned steam in the question, but we know that steam is just water vapor, and CO, carbon monoxide. This equals Kc. And then that's your full equation for full marks. That's your whole equilibrium constant Kc. So for this, you'll receive 6 marks. And again, nice and easy. The one thing to look at here is just make sure you put it in square brackets and that you put your products over your reactants. And part 3 to this question is telling us at equilibrium at temperature T, there was 0.8 moles of hydrogen gas in the container. Calculate the value of Kc for this equilibrium. So we're going to be using the Kc that we worked out in the second part of this question and just filling in our values. So what I'd like to do with these straight away is just write down what we know. So write out your equation and write down the values that we know. Now I have everything written out with the equation above it and our values below it for everything that we know at this point. So what I'll look at straight away here is look at the right hand side with the value we were just given. So it's telling us that 0.8 moles of hydrogen gas was in the container. So this is when we've reached equilibrium. So we know that the ratio between the hydrogen and the carbon dioxide, which are both on the same side, will be the same. And since they're in a 1-to-1 ratio, they're going to have the same amount of moles. So we can say then here that carbon dioxide also has 0.8 moles. Now we get over to the left-hand side, and this is where people would definitely get caught out in this year's question. So at the start of this question, we are told there's 4 moles of water and 1 mole of carbon monoxide mixed together. But that's at the start. That's not at equilibrium. So now we have to work out what it is at equilibrium because that's what we need for the Kc value. The Kc value is a constant at equilibrium. So if we just look over on the right-hand side, we can see that there is 0.8 moles of hydrogen here and 0.8 moles of carbon dioxide here. So these are going to have to come from reacting the water and the carbon monoxide. And since the water and carbon monoxide are in the same ratio, they're 1-to-1, they're going to lose the same amount of moles. So if we take 0.8 off each of these, and you could throw this into a calculator if you wanted just to be sure of it, but this is 3.2 moles, and this is 0.2 moles. And then that is all our values at equilibrium. That's all our concentrations. So we just fill that into what we worked out in part 2, our equation for our Kc value, and then we get an answer for our Kc. And then filling in our values. So we have our Kc here from part 2. So we have 0.8 for our hydrogen, 0.8 for our carbon dioxide. Our water is 3.2 moles. And our carbon monoxide is 0.2 moles. I've just put in square brackets here again. You don't necessarily need them at this point since you're not looking at the concentrations. It's just kind of a force of habit that when you're doing these questions with Kc, you can use square brackets. What the brackets mean here is just that we're multiplying the top and we're multiplying the bottom. We'll throw this into a calculator and get our final answer out. And then just to throwing this into our calculator, so as we said, 0.8 multiplied by 0.8 divided by 3.2 times 0.2. That'll just give us an answer of 1. So our Kc in this case is 1. And then for working out this value of 1 for our Kc, we've received 3 marks and we received an additional 6 marks for working out all our initial values. It's a total of 9 marks there, which is not a whole lot of work there. The thought was more difficult in this. Like, it was more difficult to come up with the answer, but the mathematics and nothing like that was too difficult since we already found it in part 2. We're flying through this question, so we've part A, I, and II done for 20 marks. Like, where would you find it on the exam paper for the amount of work we've just done? Nice and easy to pick up those marks. We'll fly into part B now, part I and II. So there's quite a lot to this first part, and we'll just go through and pick out the important bits of this. So if the same reaction had been carried out at the same temperature T, in the same container with an initial mixture of 2.5 moles of steam, so again, important information, and 2.5 moles of carbon monoxide, the value Kc would not change from value calculated in part AII above. Explain why the value of Kc would not change. So why doesn't the Kc value change? So we're told that we have the same temperature T in both cases, and we know that Kc is only affected by temperature. So that's why it doesn't change. There's no change to the temperature, so Kc doesn't change at all. And for this, you pick up 3 marks. And again, just a really simple bit of information that you'll know from working with Kc values. So it's nice and easy marks to pick up in this case. And then the second part of this question, they're asking us to calculate the mass of carbon dioxide present in the container at equilibrium, as we saw in part B above. So I have a neat trick for this one. It's just a box you draw out and fill in your information, and you'll come to the answer very naturally. So now, this is the box you draw out. It's very simple, and I'll go through it as we're going through the question and explain what each part of it means. So it's called a rice box. So we have R, which is our reaction, on top. I, our initial concentration. C is the change, and then E is at equilibrium. So we'll start out, we have our equation written out on top, and then we'll fill in the values that we know. So in part BI, they told us that we have 2.5 moles of water, and that we have 2.5 moles of carbon monoxide. And initially, since these have just been put into the container and no reaction has happened yet, we're going to have 0 hydrogen and 0 carbon dioxide. And then we have to look at our change. So what is changing? Since these are all in a 1:1:1:1 ratio, it's nice and easy in this case. So we don't know how many hydrogen moles and how many moles of carbon dioxide we're going to have at the end. So we just assign a random value for these, which we're going to call x. So if we say that hydrogen gets 1x moles and carbon dioxide gets 1x moles, then water and carbon monoxide are going to have to lose that amount of moles. So water will lose x, and so will carbon monoxide. So then we move down to the next box. In our rice box, we know that our water will be 2.5 minus x moles. So will our carbon monoxide, so 2.5 minus x. Our hydrogen will be x, and our carbon dioxide will also be x. And then at this point, that's when the Kc comes back in. So we've already calculated our value of Kc, and since Kc is a constant, it's going to be the same whatever values you put in. So we fill in these values that we've just found at equilibrium into our expression for Kc, and then we can work out what x is and then work out the mass of carbon dioxide at the end. So as we said earlier, our Kc value was worked out to be 1. And we know that Kc is just the products over the reactants. So we know that the top will be x multiplied by x, or x squared. And this is going to be divided by 2.5 minus x times 2.5 minus x. So you could square this as well. And this is going to equal 1. And that's just a simple bit of algebra to work out your value of x. So we're just going to move this around and find out our value of x. We say here that x squared, and we're going to multiply across by 2.5 minus x squared, and that times 1 is just going to be the same thing. So this equals 2.5 minus x to be squared, and then just expand this out and we'll solve for x. So x squared equals, so then just to multiplying out the bracket, you can expand it if you want. So just 2.5 times 2.5 minus x. So then with the bracket expanded out, the multiplication will be a lot easier. So x squared equals, so you multiply this one first, 2.5 times 2.5, which you can throw into your calculator if you want, but 6.25. And then we'll multiply that by the minus x, so minus 2.5x. And then this x, we'll multiply these out, minus x times 2.5 is another minus 2.5x. Then finally, minus x times minus x is just positive x squared. So then we're left with this equation, and then just simplifying this. So we have x squared on the left and x squared on the right. These cancel each other out. So we have 6.25 and negative 2.5, and negative 2.5 would be negative 5x. You say this equals 0. 6.25 equals 5x. If we divide both sides by 5, throw this one into our calculator just to have a better look, because it's a bit of a complicated one, and then we'll find our value of x. And then throwing this into our calculator, so 6.25 divided by 5 will give us our x value of 1.25. So we have x equals 1.25 moles of carbon dioxide, and what are we looking for? We're looking for our mass. We're going to look for our favourite formula, N equals M over MR. If we manipulate this formula just a small bit so that we can get our N multiplied by our MR, so we can find our mass. So N multiplied by MR equals mass. We have our number of moles, which is 1.25. Multiply this by our MR of carbon dioxide. So this is where you go to your periodic table and find your molecular weights for carbon and oxygen. So we know that we have one carbon, which is 12, and then 2 times 16, which is the molecular weight of oxygen. Again, throw this into our calculator, we'll find our mass, and then that's the end of this question, all done. Throwing this into our calculator as we have it written down here, 1.25 multiplied by a bracket 12 plus 2 times 16 bracket, and we have a mass of 55 grams. This value will always come out as grams, so write that down, and then we'll go through what we got for this question. So the marking for this question, for getting 55 grams of carbon dioxide, you received a total of 12 marks. So these came from different places. You got 3 marks for doing as we did in the rice box. Got another 3 marks for finding out our Kc value while the x's were included. You got another 2 marks for working out the value of x to be 1.25. You got 2 marks for working out your MR to be 44, or as we've done here, it's also acceptable. And then the last 2 marks were for the mass of 55 grams. So with that, there is quite a bit of working out to do with it, but it really is just step by step. So you do your rice box, write out your equation, get your initial values for your concentrations of all your compounds, then do plus or minus x, whatever way you have to do it, work out an equation for x using your Kc value that you worked out, then you solve for x, and then you go on to find whatever they're asking you for. They might ask you for a volume, or in this case, as we have, a mass, and then that's usually how these questions go. They're very predictable, and it's a good skill to have that you can just be able to go through it systematically, and that's what the rice box really helps with doing. It really shows clearly what the next step is. Going back to our main question now, we have part B completely done, I and II, for a total of 15 marks there. Again, as I said, there's lots of working out to do, but none of it is too difficult at the end of the day. Just a small bit of algebra will be kind of the trickiest bit of that. We'll fly on now to part C, I, and II, and then that's it. The end of this question, really short question, really nice, easy marks to pick up. So these next 3 questions, they're all going to be justify questions. So you're going to have to write out what your answer is and then justify it. It's very important that you have both points to that, since there is separate marks going for each of them. So getting into the first one here, state the effect, if any, of decreasing the pressure in the container on the percentage conversion of steam to hydrogen. Justify your answer. So yet again, this is very much like one of the KC questions. The pressure is not affected since there's the same number of moles on both sides. So there's no change, no effect. The only time you would see an effect with pressure changes is if there was an imbalance, if say there was 4 moles on the left hand side and only 2 moles on the right hand side. But in our case, as we saw, it was a ratio of 1 to 1, so 2 on the left, and then 1 and 1 on the right, so 2 on the right. So they're perfectly balanced in terms of number of moles. So they'll be at the same pressures. And then for this question, you received a total of 5 marks. And then on to part 2. As I said, these are all justifications. So answer and then justify. How could the value of Kc be increased for this equilibrium reaction? Justify your answer. And the answer here is reduced temperature, since the forward reaction is exothermic. So again for this, another 5 marks. Quick and easy to pick up. Just a bit of thinking behind this one. So the reason in this case that we know the reaction is exothermic is all the way up at the top here next to the equation. We have delta H, which is negative 38.8 kilojoules per mole. So what does delta H mean? It's the change in temperature of the forward reaction. And then what does the value tell us? So it's a negative number. We're losing negative 38.8 kilojoules per mole of heat in this reaction on the forward reaction. It's very important to remember that. So that tells us that it's exothermic. It's expressing heat out into the environment. So in the case of an exothermic reaction, as we have here, you reduce the temperature, but if it was endothermic, you'd increase the temperature to increase the value of Kc. And then the final part of this question, state the effect of using a catalyst on the value of Kc at temperature T. As we said earlier, the value of Kc can only be changed by temperature. In this case, the catalyst can only increase or decrease the rate. It only changes the rate. It has no effect on the Kc. And then finally, for this one, you received 5 marks. And again, this was a justification, so you need both parts to state that it had no effect and then justify your answer. This year, they also accepted a few different justifications. So you could say that the rate of the forward and reverse reactions affected equally. Only the rate was affected, and catalyst only affects the time taken to reach equilibrium. So these are all talking about rate. I think it's a lot easier just to think about it with temperature and think that temperature is the only thing that changes the Kc. Now, and that's it. We've part C done, I, II, and III for the total of 15 marks there at the end, and we got our total 50 marks for this full question. As I said with these questions about chemical equilibrium, they're very similar and they're very predictable of what's going to come up. You're usually going to have a bit of a talk about the Kc value and work out a Kc value. Then you have to go through and do your rice box as we did and calculate either a mass or a volume or something like that. And then there'll be probably thrown in a few definitions as well. But that's usually it for this question. It's a very nice question to do on the day because you have a good idea of what it's going to be like. So that's all from me. I hope this video was helpful.